The limitation of Rutherford's model was that he said an electron revolves around the nucleus. Why are both of you struggling out there? There is so much of space out here. And you all don't switch on the fan. Okay, your wish. So Rutherford said that the electrons revolve around the nucleus. Now the problem is, you just press the button out there. Yes. Yeah. Rutherford said that the electrons revolve around the nucleus. An electron being a charged particle, if it undergoes a circular motion, then it will emit radiation. Radiation means in the form of waves, and once you emit radiation, you will no longer be able to hold your circular path or whatever it is. You will follow a spiral path, and eventually you will collide with the nucleus, thus raising serious questions upon the stability of the atom. So this model has to be now superseded by some other person's model. We hold our discussion here for the time being. Okay, and we come to one more thing, the subatomic particles. So by now we are aware of electron, we are aware of proton, and if I compare them, okay, the proton has been conceptualized to be residing in the nucleus, and the proton is a positively charged particle. By now a very heavy particle, because the nucleus was supposed to be heavy, so the proton must be heavy. And when I compare between the electron and the electron is a negatively charged particle, the proton is a positively charged particle. Their magnitude of charge is same. Okay, if you don't know the real values also, and we talk about relative, so if this is -1, this is +1, relative wise they are same. But when we talk about mass, the mass of the proton is much more. Okay, so if I talk about the mass of an electron, the mass of an electron is approximately 1/1840 times the mass of a proton, which means an electron is almost non-existent. It's like a cloud. So by that time, mass spectrography was also there. Okay, and all the protons being together, the nucleus is supposed to be the energy source of the atom. Okay, so the nucleus's mass was not tallying only with the mass of the proton, right? At your level it's this much, plus all the positive particles together, you must have to have diffusers. So another particle was thought of residing in the nucleus, and the other particle is known as the neutron. The year 1932, the person who discovers it is James Chadwick. Okay, James Chadwick is actually a Jew. He was even imprisoned by the Nazi army. So neutron has a mass which is absolutely comparable to the proton mass. Okay, however, this fellow is electrically neutral. So we come a long way now. Our atom model right now has a nucleus which has two subatomic particles, the protons and the neutrons. Protons and neutrons being almost equivalent in mass, almost equal. However, the neutron is electrically neutral, right? Together they are known as the nucleons. Understood? Fine. Now we go back to our story and now need to carry forward from limitations of Rutherford's model. After Rutherford's model, we come what is known as the Bohr's model, named after Danish scientist Niels Bohr. Okay. Now all these studies were done when you go to grade 11, you will study about hydrogen spectrum. These are all studies are all based on the hydrogen atom. They are not based on some other atoms. These studies were all based on hydrogen atom. And Bohr, what we use the word is called postulates. Bohr's postulates. Postulates, and there is one more word we use in mathematics called axioms. Postulates and axioms are some starting statements which are supposed and believed to be true in order for the study to go ahead. However, nothing so far has been found which contradicts your assumed statement. That is called a postulate we usually say in science. Axiom is the word we usually say in maths. Okay, like a point does not have any length, breadth or height. However, collection of point is a circumference, right? I don't have length, breadth, he doesn't have length, breadth. Millions of us don't have length breadth, then how are we having? So axioms and postulates are starting statements which are said to be or believed to be true in order for a study to propagate. So Bohr's model of an atom is more or less supported by what is called Bohr's postulate. What all did he say? Right. So let's first understand again what Rutherford said. Rutherford said that the entire mass of the atom is concentrated in the center in a very small portion, very compact, positively charged, and almost supposed to carry almost the heart of the atom, which carries all mass. And he coined this as nucleus. And he said electrons revolve around the nucleus just as planets revolve around the sun. That's it. And could not explain the stability from the energy loss perspective. Now, whatever Bohr will say, you will say, even I could have said that, okay? So, Bohr's first postulate, okay? And these are questions that will be asked to you, so you should know. Bohr says, electrons do not just freely revolve around nucleus, but they do so in fixed circular paths called orbits, which are designated with a definite amount, or you can say in this word, you can also use the word fixed amount, definite or fixed amount of energy. And so each orbit is also termed as an energy level. As you are progressing for the rest of the course in this year, change one paradigm in your life. Do not start writing whatever I write. The class gets recorded. I might be writing more than the book. The book will have a much more clearer English definition in shorter, compact words. Your job here is to understand. If you spend more time on writing straight away, then you will, that does not mean that, don't be either a boiler or a refrigerator. If I'm at your place, you know how I will attend this class. I will come to this class with only white A4 pages. And paper clips, I will have paper clip. And I'll carry one pencil and I'll carry one pen. And I'll start, asterisk, what is my sir teaching today? Okay, recap. He had Bohr's, because my job should be to absorb more. Rutherford's drawback, he recapped this. Then he spoke a little bit about postulates and axioms, something of interest. I can look up to the internet and add to what he said. That makes you a better learner next time. And you can come and say, sir, you said about axioms, this is also true about axioms. Ye wala aapka brain churn nahi ho raha hai. You're busy writing this. Then next sir spoke about Niels Bohr, and he said he was a Danish guy. So you can take some time to, all your NCERT books have about Niels Bohr. So let's see about Niels Bohr a little bit, thoda sa interest. Then he was talking about postulates, and he wrote the first postulate. And in this first postulate, I'll just mention the keyword. Electrons, kitna kuch likh diya hai. If you start copying this straight away, you have not understood anything. I would be more happy if you observe. Electrons do not just freely revolve. ऐसे ही नहीं घूमते हैं, just ऐसे नहीं घूमते हैं, but they do so in fixed circular paths. Keyword called orbits. That means if I'm the student, I will write electrons, no random movement, fixed path movement, orbits. These are my keywords. When I go home today, sir might have uploaded this video or may not. I'll open my textbook and see, am I able to correlate? That's how you'll remember. Point is that you'll write all this down and not study this at all, because this is not being taught in school right now. So I'll not study. And then 8 days later you'll come. इसलिए तो पढ़ाई नहीं हो रहा है. It's not that you all are weak children. Till grade 8 you all have scored good. But from grade 9, we have to change the way. You can't bat in Australia like the way you're batting in IPL. That does not mean you're and class Form is temporary, class is permanent. If Rohit Sharma is a good batsman, he scores a century there also. He doesn't entertain crowd there. Aapka class develop hona hai. So it's written, and those so in fixed circular or paths called orbits. What's so special about the orbit? Which are designated, means if I'm in orbit, I will be designated with a definite or a fixed amount of energy. And then my orbit name transforms into energy level. And if I want to draw pictorially about what I wrote out here, it's something like there is a nucleus. The electron will just not simply revolve, it will revolve in an orbit. That's what it's trying to say. And this is called an orbit. And this fellow has fixed energy. Even if you draw this diagram, your ability to draw a diagram is also reducing by listening to this. I would be more happy. See, drawing this is much more faster. You should be very quick to come back to me to listen what I'm saying. आप इसी में time देते हो ज़्यादा. अब orbit draw कर लो फटाक से. And this has been written in English, right? Fixed circular orbit, fixed energy, and as such, this can also be called as a energy level. So now ask yourself, what is an energy level? An energy level is a fixed circular orbit defined with a fixed amount of energy in which an electron is revolving around the nucleus. What's special about it? This was coined by Bohr. Bohr said that electrons don't just... Now, what is Bohr targeting? Remember, he has to target that point where the electron will lose energy and collide. He has to counter that. Then only you will accept him. So he says that the electrons move in circular path, and these circular paths are called orbits, which have fixed amount of energy, right? These orbits are further named as K, L, M, N, based on their distance from the nucleus. The nearest one will be called K, the next nearest one will be L, M, and N. So orbits can have different names. Each orbit has a designated amount of energy, fixed energy. Understood? Fine. Now, next thing we understand is, say you are at K and you are at L. Understood? Our next postulate. Now, I'm going to speak about it. I'll deliberately not write. You try and understand. The first postulate says electron revolve around fixed circular paths called orbits. Each orbit has a designated fixed amount of energy, and as such, it is called an energy level. So K is an energy level, L is an energy level. An electron can be in K, it can be in L. Right? As the next postulate, Bohr's second postulate, it says, as long as an electron continues to stay in an orbit or in a particular energy level, फिर लिख रहे हो, मत लिखो, ये आदत छोड़ दो. You have to counter Rutherford's limitation, which is yet not done. Why are we studying this? Because we are countering Rutherford's limitation. What is the limitation? That the electron will go and collide. Why does it collide? Because that goddamn poor thing is losing energy. You have to counter that. He says, as long as an electron stays in his orbit or energy level, it neither gains energy nor loses energy. ये तो मैं पढ़ा चुका हूँ, फिर भी double पढ़ा रहा हूँ. That's why, and you can ask me now, sir, who said that? Did you go and actually see? You are deliberately trying to take a name by keeping Rutherford's model and yet removing that weakness of that model. That's why it is called postulate. I'm proposing so. Otherwise, you prove me wrong. Technology is not strong enough to prove me wrong. Things are happening the way I'm saying. So he says, as long as an electron stays in an orbit, the electron neither loses energy nor it gains energy. So this nullifies Rutherford's, because if you're in circular motion, you should lose energy. He says, as long as you are in a fixed circular orbit, neither you will lose energy nor you will gain energy. So this is holding now, this statement is defending the planetary model. Are you getting it? The only difference with the planetary model is that he has introduced a concept called orbit or energy level, and different energy levels, right? The first postulate says electron does not roam away. It revolves only in circular path called orbit. Each orbit is designated with an energy quantity, fixed energy, right? Say suppose here I have got x joules, electron energies are not in x joules, they are in a unit called electron volt, you will not understand. For you, joules, you know, this is in so much joules, this is y joules. As long as you are in the x orbit, your energy neither becomes x minus delta, nor does it become x plus delta. Have you understood? Okay. Our third postulate. Now, this is very much similar to something like grades in a school. You're in grade 9. If I uplift your grade, I have to award you grade 10 now. I can't give you grade 9.3 months. ऐसा नहीं है. And if I downgrade you, I have to take you to grade 8. Understood? So if an electron wants to say, so these are my orbits. If an electron jumps out, it will jump from K to L, or it can jump from K to M, not somewhere in between. And if you are jumping in orbit to orbit, understood? Now this has got an energy level X. This has got an energy level Y. So between these two orbits, there will be a X minus Y energy difference. Do you agree or not? Right? Achha, next thing. This is electron and this is a positively charged nucleus. Don't you think the nucleus will be attracting the electron? Electron is a slave of the nucleus. Believe it like that. Every time you want to take the electron for a ride, you have to pay the nucleus. Otherwise, the nucleus is not going to release it. You have to pay the nucleus. That means when an electron jumps out, it will absorb energy. And it will absorb how much energy? X minus Y extra energy you have to supply. Already it has got X. X minus Y is the difference between these two. Okay, Y minus X. You take the modulus of it. Now, how does it matter? You know, do not develop. I'm talking about difference. Your age and my age, the difference is 36 years. Me minus you is also 36. You minus me is also 36. I'm talking about the modulus. So my age plus give another 36, then only you'll go there. Have you understood? And if you want to come back, you will release so much of energy. There is not a single electron, and this was later found true. Now a postulate, but the quantum model finds it absolutely true. Absolutely true. So, ऐਵੇਂ नहीं बोला है, कुछ तो reason है. So we write, electron jumps out to a higher energy level by absorbing energy. Electrons absorb energy to move out to a higher energy level and release the same amount of energy by absorbing energy. See, it's like this. Understand? Look at me. From grade 9 to 10, you have to absorb the academics of 9. And then only you can go to 10. Sir, I want to come back from 10 to 9. Then forget so much of academics and come back to 9. That is fixed. So an electron absorbs energy to move out to a higher orbit. Now you can ask, sir, if I forget in the exam whether I absorb energy or I release, then follow the slave story. Electron is the slave of the nucleus. And you are asking the electron, chal na thoda ghum ke aate hain. It pulls me and keeps me. Keep some energy with you. Release him. And when he comes back, nucleus says, take back your money. He has come back. My slave has come back. Easy story. So electron absorbs a definite amount of energy. You can write, electron absorbs a definite amount of energy. And every time you do that, like a K to L transition, if it is a X minus Y, every time it will be X minus Y. And L to K transition will also be X minus Y. So electron absorbs a definite amount of energy to move to a higher energy level and releases the same amount of energy while it jumps into a lower energy level. Have you understood? So you should ask, what is the real life importance of this? When you heat a gas, and you go to, when you will be going for example, you have not done any chemistry practical, so we have got something called flame test. Every element will show different colors. Like sodium shows a very orangish color. Any other, for metals, the best way is to do a flame test. Take a piece of the metal and put it into the fire. Everyone shows a different color. where is this color coming from? This color is coming from because the electron is absorbing that energy, absorbing. So this from the spectrum is so many colors. You absorb out one fragment, then it's a new color that is produced. And rainbow is a spectrum. If I absorb energy from the rainbow, then will I see something? Everything mixes, you see white. If you pull out some green or some color, the color of this will change. So you absorb, so the color changes. And when you release, you again are releasing this energy. This is called absorption and emission spectrums. This you will study in grade 11. What happens to that energy? And at that state, we call the atom is in excited state. You have added more energy to the electron. The electron will absorb that energy. As a result, the spectrum will change. Yahi Bohr's, this is the same continuation you'll do in 11, but at your level, 3 postulates are very important for you. An electron revolves in a fixed circular path, just doesn't revolve randomly. Fixed circular path, called orbits, designated with fixed amount of energy, so called energy level. Second point, as long as an electron stays in an energy level, it neither gains energy nor loses energy. Electrons can jump to higher energy level or fall back to their original level. In such a case, an electron absorbs energy to get out and releases the same amount of energy to get in. Means if you are doing a K to L transition, if you absorb X, you will release same X to come back from there. Clear हुआ इतना? ठीक है? Good. चलो. So this is Bohr's postulate, and this completes at your level to understand what is known as the models of atom. So you studied about the Thomson model, you studied about, that is called the plum and pudding model, you studied Rutherford's model, you studied Bohr's model. Bohr, we don't call it as a model, we say more as Bohr's postulates. Brings you now to another concept called, like you have been briefed a lot about what is an element, a pure substance made up of only one kind of particle, which is known as an atom. These are all elements and they are always represented by their atoms, right? Now, every element is represented by its atom, and this atom is represented by something which is known as symbol. Symbol concept was proposed by Berzelius. I don't know, double L or L, yeah. Berzelius. Before this, we had, now in the new course, you don't study about Dalton's model of an atom. John Dalton was the first person who gives Dalton's atomic theory, of which everything is wrong today. But we still study that, but in your new syllabus, it is no more there. So, is it there? I have not seen it. It's not there. So they'll only talk about, Dalton had coined names of elements differently by, by giving different symbols and all. But the way we now do is we use symbol. Symbol means we will be using the letters of English. The English alphabets will be used. Okay. And they will be in caps if you are a single alphabet, or you will be caps followed by lowercase, and this is restricted to maximum 2 count only, and this is based on either the Latin name or the English name, right? For example, if you are naming something called oxygen, it is named after the English name O, right? After this, if an element is discovered with the letter O, which is there, in that case, we will take the next letter also, which is very common, like say carbon. Carbon is denoted with C. However, cadmium is denoted by CD. Then copper becomes Cu because it takes the Latin name cuprum, right? Potassium becomes K because it takes the Latin name calcium. Sodium becomes Na because it takes the Latin name natrium. So this is the order. Okay, clear? Cadmium, copper, then cesium is Cs because C is gone. Clear? Symbols are clear. So 1 to 20 you should be knowing. I have done many a times. So you should be knowing 1 to 20 and how to construct the periodic table and make it easily to know from 1 to 20. Okay, this is done. Oh, वो नहीं है लीना की रफ्से फरियाद will tell you group. At your level in grade 9, you should know group 1, group 2. Group 3 is not of your use. Group 13, 14, 15, 16, 17, 18. And you should know how many periods. The first period will only have hydrogen and helium. The second period will have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then comes your third period. Third period will have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Then comes your fourth period. This will be what? Potassium, and this will be calcium. That's all. That's 20. अब समझ में आ रहा है कितना डेल्टा पड़ रहा है? Because I am going fast because these are taught. 6-7 classes of bridging was done. Okay. The next comes electronic configuration. Yes, I'm happy at least one person is saying you told that. So how does electrons fill into an atom? By the rule of 2n square. So let's do a good revision. Okay, yeah, octet and duplet will come later. First is 2n square. The 2n square tells you the maximum number of electrons that can be accommodated in the energy levels K, L, M, N, where N is equal to 1, N equal to 2, N equal to 3, N equal to 4, right? So 2n square, 2 into 1 square means maximum number of electrons will be 2, 2 into 2 square will be 8, 3 square is 9, 18, and 4 square 16, 32. Right? Now, if you are a first shell entity or a one shell entity, then we bring the concept of duplet. And this is my what shell? K shell. So it can have maximum of 2 electrons. Hydrogen has got 1, helium has got 2. Job problem starts when lithium comes up. So when lithium comes up, lithium's atomic number is 3. So atomic number 3 means it has got 3 electrons now. So the first shell is already occupied. So the receptionist now will give you the key for the next floor. So the next shell, 1. Now this will go on filling. And this will fill to octet. However, there is a catch. If you are the valence shell, then you can have only how many electrons? 8 electrons in the outermost shell. This is a catch also. That's the reason. As of now, I'll just cover about, say, argon. Okay, argon. Can you project what should be the atomic number of argon? 20 is calcium, 19 is potassium, 18 is argon. So let's break 18. 18 means the first orbit will have 2 electrons. Then 8 anyway we are giving 8. 2 plus 8, 10. So another 8 remaining, 8. So it is 288 is the electronic configuration. Let's check. Is it following? First shell 2, second shell 8, and the last shell can have only 8 electrons. Done. Right? Now, if we go by our logic, this is K, this is L, this is M. But M can still have 18 electrons. After argon comes potassium, whose atomic number is 19. 19, right? 19 means K, L, M. I can load 2 here. I can load 8 here. I should be able to load 9 out here because 18 electrons is the capacity. But again, here is the exception rule that if you are the valence shell, you can only have 8 electrons. So what do? We now keep 8 electrons out here. That 1 electron more, so 1 more room will be opened up and that electron will go here. This you should remember. And then comes calcium. Calcium is 20. So K, L, M, N. So 2, 8, 8, 2. After that, d orbitals open up. That's where your grade, what you call 10 knowledge, will go for a toss. This is period 4. At fourth period or the fourth shell, the 3d orbitals will open up. And to understand that, you should be in grade 11 to first understand electron filling. So this electron filling will be thrown. And then you will learn about the principle called the off-bow principle. Off-bow principle of electron filling. Yeah. Postulated by or off-bow. Very good. That's absolutely nonsense. Off-bow is not a person. Off-bow in German means building up. Off-bow नाम का कोई आदमी नहीं था. Off-bow's principle, when we say who gave off-bow's theory, off-bow. No, off-bow means building up. Okay, this is the and then you will see completely different. You will have to understand what is an orbit and all. So electronic configuration. Today you understood about Bohr's postulates, right? Bohr's postulate opened the Pandora's box of something called an orbit, energy level, fixed amount of energy, no loss of energy, absorption or release of equal amount of energy when I go out or I come back. It's just like taking, I don't know how many of your schools follow the system of pass. In our school, we had a pass system. Like when the class is on and you need to go to the washroom or anywhere, then from the monitor, you have to have a pass. You should not be caught outside without a pass. If you're caught outside without a pass, your ears holding and you're standing there, that means you're aimlessly loitering. The school is on. Anyone can check your pass. A teacher can say, where are you going? Where's your pass? So you should be able to display your pass. No pass means you're wahi pe. No, but that's why 2 passes will be there. 2 boy pass, 2 girl. That doesn't mean all of you are going to the washroom at the same time. 2 boys pass, 2 girls pass. And pass should be there. Anytime checked means pass. Maybe I may have punished you. Go and stand outside the class. She's much more clever girl. She takes some papers and roams, some music competition, name taking. Nobody gets to know that she's actually punished. And in our time, it was ruthless. When you'll be getting out of the class, his brother or somebody may notice you. By the time you come back to the bus in the evening, message has spread. Ritisha was turned out of the class. Rishika. And before you reach your home, the primary wale to already ghar ja chuke hai na. Their parents have already told your parents, today we saw your daughter standing outside. Yeah, done. This one. Okay, our next concept. So we're done with this. Okay, and next are also 2 very easy things. So they are, hey, Alexa, stop. Atomic number. Which one?
There's a button on top of it.
No. Why? She's such a lovely voice. Reminds me of my girlfriend. Why should I mute her? Atomic number. Atomic number, you know? Anyone can define? Atomic number is the count of protons in a neutral atom, right? In a neutral atom, the count of protons. And sometimes it will tally with the count of electrons when the atom is electrically neutral. But that does not mean that you should go by the electron count, always go by the proton count, okay? Atomic number, though maybe in your book or not there, was given by Henry Moseley. Henry Moseley was the person who, ऐसे ही है. तब हमारे देश में ज्ञान नहीं था ना बेटा. Westerns were, we had lot of things were done from India also. They never documented. हाँ, नाम से ऑटोमेटिक कितने नाम पढ़े हैं आपने? आपने एक नाम पढ़ा है जे थॉमसन, ऑयजन गोल्डस्टीन, जेम्स चैडविक, अर्नस्ट रदरफोर्ड. ये आपके कोर्स में. हाँ, जेम्स चार्ल्स, वो सब मैंने दिया है. मैंने आपको जेम्स चार्ल्स मैक्सवेल दिया है, गीगर एंड मार्शडन दिया है, ठीक है? और कौन? और कौन है? अर्नस्ट रदरफोर्ड तो हो लिया, गिन लिया है. अर्नस्ट रदरफोर्ड, नील्स बोर, Eugen Goldstein, count कर लिया. So you go by start. See, J.J. Thomson is the first one, cathode ray. Eugen Goldstein, anode ray. Then Thomson's हो गया, ये हो गया. Rutherford's model of atom. Additionally, you can know about Giger and Marsden. After Rutherford's model of atom comes Niels Bohr, and James Charles Maxwell is what I have given you with Rutherford. So Niels Bohr comes up. Niels Bohr gone, then comes Berzelius. That is there in your textbook. Henry Moseley, I'm giving you from my side. Henry Moseley was the person who actually went for atomic number.
Yeah.
Atomic numbers. Conceptualize the word atomic number. Muesli. हाँ, दूध में डुबो के खा लेना उसको. ठीक है? So atomic number is fine, clear? Okay. The next concept is mass number. I think mass number should also be clear. Mass number is the total number of nucleons. That is, it is the count of protons and neutrons. So you might get some problems in which they will ask you to estimate, right? Say for example, we take an atom of oxygen. The atomic number is always denoted by Z. The mass number is denoted by A. So it will be Z here and A here. So oxygen will be written as 8, 16. So can you predict how many numbers of neutrons are there? 8 protons means 8 neutrons must be there. ठीक है ना? Clear है? So this is also not that tough. Okay. This gone. Anybody? Acha. Next our topic should be yeah. Now valency, valence shell, all those stories. Okay. शादी वाला यहाँ नहीं है. शादी वाला was an advanced thing. But for that you need to understand valence shell. Come on, let's see. Do you know or not? What is a valence shell? Outermost shell of an atom is known as the valence shell, and the electrons residing on it are known as valence electrons. Understood? These valence electrons will play a major role in the combining capacity of an atom, which in my language used to say shadi karna. Combining capacity, whether somebody will combine with another person or not, that will be decided by the valence electrons, because end of the day you have to look for stability, which is an abstract word. In mathematics it's all about getting the octet. So let's take one example. I have got sodium with me, and the atomic number of sodium is how much? Tell me. 11. Okay, and I've got chlorine with me, which is just before argon, so it should be 17. So we'll see the combining capacity now. So in order for this, we'll to see the electronic configuration, it will be 281, and this is what is important for us, the valence electron, and this will be 287, right? And this brings up the concept. So sodium needs 7 electrons to get an octet, which is very difficult, because how many electrons can you get maximum? 3. You can maximum get 3, or you can lose 3. And sharing maximum can be 4, which we'll deal in later classes. So this fellow needs 1 electron. This fellow needs 7 electrons. Not possible. So we say you kill 1 electron, you donate this electron, because if you donate, then now you become 2-shell organism and you have got an octet, and this fellow continues to be the 3-shell organism and has an octet, right? So it will be, if we try to see, it's something like this. Sodium, right? Sodium has got how many electrons here? 2 electrons. After that, how many electrons? 1, 2, Na aayega, sorry, 2, 3, 4, 5, 6, 7, 8, and then it has 1 more electron, right? And this is 1 electron. So our sodium actually in this process will convert into a positively charged ion, which is called a cation. So when it becomes a cation, it's sodium 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8, and now we put it in square brackets and show a plus here, and we release that electron. So 1 electron. You never show as minus electron. You always say this got converted to sodium ion. So this is sodium atom. This is sodium atom. In grade 10 you have to do all these things. This is sodium ion, and this is electron. Yes, and specifically if you want to know, this is a cation. So this electron will be now consumed by chlorine. So shall we draw our chlorine structure? Same board, same screen. So let us make it a little bit smaller, smaller, and keep it here. Ow. Right? And let's look for chlorine. So let's make chlorine. Chlorine, 2 electrons. Then 1, 2, 3, 4, 5, 6, 7, 8, and then 7 electrons. 1, 2, 3, 4, 5, 6, 7. Then please, sir, don't do so much of hard work. Copy this and keep it because it will be useful for you. Okay? This fellow takes that electron and converts into what now? Now this. So I am showing that electron with a different color. So that electron has come here and as such will develop now a negative charge. So what is the name of this? What is the name of this? Chlorine atom. What is this? Gaya. Chloride. Chloride ion. Non-metals always end with IDE. Oxide, carbide, chloride. कुछ फायदा नहीं है वो सब पढ़ा के. Next year से I will no more have those bridging classes. It's just waste of my energy. और नहीं तो क्या? सारे बच्चे बोलते, आप बोल रहे हैं, मुझे अच्छा लगा. ठीक है? Anyone has the exploration book? अच्छा. One is this, what do you call, valence. Okay, now we'll talk a little bit about valency. So, isobars and isotopes I'll talk. So, valency, you know, tendency of an atom to gain, lose, or share electrons in order to obtain the electronic configuration. See, in order to obtain an octet is the very grade 9-ish definition. But every time will you obtain an octet? Lithium doesn't obtain an octet. In order to obtain the electronic configuration of the nearest inert gas. If you cannot become the good child of your colony, at least become the good child of the previous colony, or become the bad child. If you can't become the good child of your colony, so let's look at this slide. Where is it? This one. Very good. So lithium. Lithium can never become neon, because for lithium to become neon, you need 7 electrons. But lithium can sacrifice 1 electron and become the good child of the previous colony, that is helium. Similarly, sodium never became argon. Sodium became neon. That's why sodium ion is 2,8. What is the electronic configuration of this? 2. This is 2,8. This is 2,8,8. Similarly, chlorine will always become the good boy of his own colony. Chlorine becomes chloride, which is 2,8. Clear? And valency tells me, so how does the valency vary if you see here? Valency here will be how much? 1. Valency is the number of electrons you can gain, lose or share. These people will always lose. Therefore, they always become positive charge. Therefore, they are metals. Metals are electropositive. Metals have electropositive valency. Metals form cations. You will never see Be2 minus. This will lose 1 electron. This will lose 2 electrons. This will lose 3 electrons. What is the formula for valence electrons?
13.
Group or Gerber. Group 1 and group 2, the valence electron is same as the group number. पूरा बोलना है. 13 to 18 क्या है? Group number minus 10. Group number minus 10. So this will be 3. This will be having how many valence electron, bacha? 3. So if you remember that way also, you can know the valency. 3 means it still needs 5 more electrons. कोई नहीं देगा. तो इन 3 बच्चों का गला घोट दो. Then this one is, this is 4. This has got 4. Neither it can lose 4 nor gain 4 but share 4. That's why carbon है यहाँ पे. Then comes nitrogen. यहाँ से लुटेरा शुरू हो जाता है. They will all steal. Nitrogen has got 5, so it can gain 3. That's why nitrogen will always form N3 minus. Clear? Understood? Fine. So valency gone. Our next topic, our next topic should be isotopes and isobars. Very good. Come to isotopes. Isotopes, you know?
I don't remember this.
Okay, let's go. Isotopes.
Did we do this in Beijing class?
Little bit we had spoken about it. Yeah, isotopes we have done. Isotopes are atoms. Isotopes are atoms which have the same atomic number but different mass numbers. Okay, isotopes are atoms
That have
of an element, or you can say atoms of an element, you can say, or atoms that have same atomic number but different. If you participate like this, I also feel happy. I get tired, but I feel happy. I got 3 classes. After I've got classes till 9 o'clock, but it feels good. Atoms of an element. Now, we will first restrict ourselves to atoms. We'll not say the word of an element. That will come clear, you'll see. Atoms that have same atomic number. If 2 atoms have the same atomic number, they must be the same element. If 2 atoms, if you have a different atomic number, then in the periodic table I should give you a different house. But your atomic number and his atomic number are same. So you are the same element. So atoms of an element. Otherwise you can say atoms which have the same. Once you have same atomic number,
you are the same.
you are the same element. That means, it's very interesting. That means I should have an element. And what is the definition of element? Element is made up of the same kind of atoms. So here there is a little bit of a contradiction. That means there is some element in this universe that is not made, means it's like this. This is an element, and the same element occurs as element, but here the atoms are different, here the atoms are different, but their atomic numbers are same. That means this element and this element are same. That means what are the 2 things? We will say, and let's consider neutral. If the atomic numbers are same, we will say NP is equal to NP. Do you agree or not? Atomic number is same. Since it is neutral, so we will say N electrons is equal to N electrons. But the definition says, so we will say NP equal to NP means Z is equal to Z, which is same atomic number but different mass number. It says the A is not equal to the A. A is made up of what? P plus N. P and P are same. That means this should be N dash. Atomic numbers are different. Atomic numbers are made up of protons and neutrons, but protons are same. Neutrons have to differ. I am 6, you are 7. Agreed? This is 3, this is 3. Now match it. इतना टाइम लगा इसको समझने में. 3 and 4. So we say isotopes are atoms of an element that have the same atomic number but different mass number, and this is due to difference in count of neutrons. So one more question might be asked to you. Isotopes differ in the count of neutrons. Wait now. So this and this, although they are the same element, they will be known as isotopes. They are like clones. Fingerprint is different. Huh.
Yeah.
29 August. July. Huh. सुनो फिर से ये डेफिनेशन पूछता है लेकिन get it clear. You are always anxious to write. Get clear. Isotopes are atoms with same atomic number but different mass number. The different mass number is attributed to the difference in the number of neutrons. Such atoms are called isotopes. It is the same element. And can I swap the screen? Huh? So there can be an element whose name is element, but the element occurs as, atoms occur as 2 different type of atoms. And both of you then will be known as isotopes.
Examples.
उसके लिए तो screen तो बदलना पड़ेगा ना. So let's look at an element. Let's look at an element called hydrogen. Hydrogen. Now, hydrogen in the universe occurs in three different forms. The most common form is hydrogen 1 1. 1 1 means P is equal to 1 and N is equal to 0. Therefore, it is 1. Correct? This form of hydrogen is known as protonium. Hydrogen also occurs in the universe as 1 2. Now, see. If you look at the periodic table, there is only one hydrogen because the periodic table is arranged with the atomic number. As long as your atomic number is same, the periodic table treats you as same. Right? This is 1 2. This is known as deuterium. Deuterium. But this is not the element name. The element name is still hydrogen. Here P is equal to 1, N is equal to 1. So see, count of neutrons. Then there is a third breed also available. This is known as heavy water. If you make water out of this, this is used in atomic power plants called heavy water, deuterium. Even in what you call hydrogen bomb, deuterium is used. Okay. Then neutron चाहिए, neutron नहीं होने से कुछ गड़बड़ नहीं हो सकता है. Then hydrogen 1 3. This is called tritium. Tritium. Here P is equal to 1, N is equal to 2. We have carbon. C611, C612 and C614. This is radioactive. All radioactives are isotopes. Uranium 235, uranium 238. Then the most common, chlorine. Chlorine. Cl17, Cl17, 35, 37. Now we have to discuss this. So if you look at the periodic table will show Cl17 35.5, which actually asks you how is a mass number 35.5? Is a proton or a neutron broken? No. This is the weighted average. Weighted average. If you take chlorine from the atmosphere, then 75% chlorine is this, 25% chlorine is this. So you take 0.75, multiply it with 35 and take 0.25 and you multiply it with 37, then you will get 35.5. That's the reason why mass numbers appear in decimal, decimal, decimal. The decimal mass number is attributed to average, weighted average, not just average, weighted average. So what are isotopes? Isotopes are atoms of an element that have the same atomic number but different mass number. The difference in their mass numbers is attributed to the count of neutrons. Examples being protonium, deuterium, tritium, and carbon 12, carbon 11, 12, 14. Carbon 14 is radioactive. All radioactives are all isotopes. Okay. Similarly, we have got one more member called isobars. Acha. Oh, sorry. We have got isobars also. Isobars are same mass number but different atomic number. Good. Chale? Okay. Then we come to isobars. This is just for knowledge purpose. So in isobars we have got argon, then potassium and calcium. If you look at their mass numbers are all 40, but this one is 18, 19 and 20. Isobars are atoms of different elements now. Isobars cannot be same elements. Jab 18, 19, 20 means roll numbers are different, right? Yeah. So isobars are atoms that have the same mass number but different atomic number. One of the examples are argon, and this is there in your syllabus. Argon, potassium and calcium. हाँ दूसरा भी है नहीं कोबाल्ट निकल और इसमें भी है आइसोबर्स.
It's basically the same as isotopes, but they are of different
isotopes will always be, see what is happening here. The whole magic is here. Mass number. Mass number is basically a total of protons and neutrons. Are you getting it? This is like theory and practical. I generally ask you how much did you score in science and you say 86. And she has also scored 86. Does not mean that both of you scored the same in theory and same in practical. As long you are 86, you are isobar. And as long as your roll numbers are same but different scores, isotopes. Isotope means an isotope can be only in a single clan. Here there can be isotope 1, isotope 2, isotope 3. Whereas when you score for IB1, IB2, IB3, isobar 3, then this is an element 1, element 2, element 3, argon, potassium, calcium. But this is in the hydrogen clan itself, carbon clan itself, chlorine clan itself, uranium clan itself. I think we are left with any other topic. और कुछ नहीं है, इस चैप्टर खत्म नहीं, क्योंकि इस चैप्टर में वैलेंसी है, वैलेंस शेल है, ऑक्टेट क्राइटेरिया है, डुप्लेट है, जिसका मेहनत मैं पहले कर चुका हूं. आपको वो पढ़ना चाहिए, then only you will enjoy this.